Hello everyone, I am Monica from BSc Chemistry Honours Final Year. Today I am going to read a chapter for audiovisual impaired student, that is use of organic and inorganic reagent in inorganic analysis. Introduction. Reagents are those compounds which are used in inorganic analysis for detection and determination of ions and molecules. A large number of organic as well as inorganic reagents have been used for this purpose. The inorganic precipitating reagents generally precipitate the inorganic species as sprangely soluble salt of hydrous oxides. The organic precipitating agent form sprangely soluble products either through coordinate linkage or through ionic linkage between the inorganic species and the organic precipitating reagents. Advantages of using organic reagents. The advantages of using organic reagents are listed below. They are more specific than conventional reagent under certain conditions. Because of this property, they can frequently be used to detect a single type of ions in a complex mixture. They can be more sensitive. Classical semi-micro methods of qualitative analysis will usually not detected much less than 100 gammas of a substance under specific test solutions. Organic reagents, on the other hand, are capable of detecting below 10 gamma and in certain cases as little as 10.3 10 to the power minus 3 gamma. They can be adopted in quantitative analysis. The organic precipitates are generally insoluble in water at given pH and can be separated, dried, and weighed. Those reactions giving colored soluble products frequently shows a regular change in color intensity with concentration of the substance under test and so are adapted to an accurate comparison with color representing concentration. This is the basic idea in the branch of calorimetry. Common properties of organic reagents. Some of the common properties of organic reagents due to which these are used in inorganic analysis for given below. Formation of colored precipitate. Organic reagents form detect direct characteristics color with the ions to be detected. For locating and point as indicators employed in volumetric titration. Formation of precipitate due to difference in solubility. This may be made on the basis of gravimetric methods. Extraction in organic solvent at controlled pH. Masking reagents. This increases the selectivity of reagents. Difference in volatility. Oxidation or reduction to the valence state. Wash liquids. The chemical nature of the organic reagent is important in determining the use of above mentioned properties. Advantages of organic reagents over inorganic reagents. It is due to the following properties that they are better precipitating reagents than inorganic reagents. Selectivity. In many cases, organic reagents are somewhat specific. For example, cobalt from nickel using alpha nitroso, beta naphthol or dimethyl glyoxime, aluminum from iron using caffeine, cadmium from copper using quinalidine acid, and thiourea can be precipitated. In some cases, adjustment of the pH will often cause precipitation of one constituent alone. By changing pH and solvent condition, one constituent after another can sometimes be quickly precipitated out. Ease of drying. Organic reagents produced compounds that have little affinity for water and dried easily at temperature low enough to prevent decomposition. Co-precipitation. Lack of ionic character of organic precipitation products greatly reduced co-precipitation in most cases. For example, the co-precipitation of sodium and potassium with magnesium is much less when the latter is precipitated by 8-hydroxyphenolene. than when it is precipitated by phosphate and oxalate. Some exceptions in metals do occur. It has been little studied but in some cases it is as bad as in inorganic precipitants. Reagents are usually insoluble in water, therefore, it is important not to add an excess of reagents. This is difficulty because there is no way to tell when sufficient reagent without excess has been added. Any excess that is insoluble would add to the weight of the precipitate. Disadvantage of organic reagents. There are unfortunately disadvantages to use organic reagents. Volatility. This is the first practical disadvantage of organic reagents because chelated compounds are non-polar. The forces between the individual molecules in the crystal are not very great. Thus, some of the metallic complexes which are precipitated in analytical chemistry are appreciably volatile, above 130 to 150 degree. Most decompose above this temperature. Therefore, the drying of precipitate should be done below 130 degrees Celsius to avoid decomposition. Impurities in reagents. It is very difficult to prepare an organic reagent of the same degree of purity. As say, inorganic compounds impurities present in organic reagents may enter into the precipitate during the precipitation and cause undesirable reaction. For example, dimethyl glyoxime exists in three forms alpha, beta, gamma. Of these, only the alpha form is the specific for nickel. While preparing dimethyl glyoxime, gamma form is also formed along with the alpha form. If the precipitation is carried out with this impure dimethyl glyoxime, then nickel will be precipitated with some other metals because alpha form is specific for nickel, whereas gamma form can precipitate other metals also. Ketoenol isomerism in such compounds as dithiazone will cause error in calorimetric work unless conditions are carefully selected. Low solubility of the reagents in water. This is the greatest disadvantage which organic precipitants have in comparison with inorganic precipitants. High molecular weight. The very high molecular weight of chelate complex formed with metal ions reduce proportionality, small error in precipitation and weighing. Colored compounds. Chelate compounds are often highly colored, and since they are usually soluble in organic solvents, they tend themselves to calorimetric and photometric methods of analysis. Solubility in organic solvents. Because of their covalent nature, Because of their covalent nature, most metal complexes with organic reagents are soluble in non-polar solvents, and chloroform begins usually the best. Such solvents are used to extract the complexes for calorimetric determination, or they may be used simply for separating one element from another. Thus, the complex of caffeine with dry positive iron is very soluble in ether and chloroform which allow one to remove large amounts of iron from solution containing aluminum. In these extraction, the pH must be carefully adjusted to give the desired separation. Important organic reagents. Some of the organic reagents which are generally used in identification of ions are discussed below. Oxygen C9H7ON. The structure of this reagent is given in figure 18.1. It is almost a colorless solid soluble in organic solvents and mineral acids. It gives yellow color which may be due to the formation of phenoid structure. It was introduced by Ham and Bug in 1927 as an analytical reagent. The number of metals gives coordination complex with this reagent. Examples of such metals are magnesium, zinc, copper, cadmium, lead, aluminum, iron, barium, gallium, thallium, zinc, etc. The formation of the complex compound with a bivalent metal ion like Zn2 plus is shown below. पिपरीन OH लिया, रिएक्ट किया Zn2 पॉजिटिव के साथ और ये बन गया और H पॉजिटिव बाहर. द क्वांटिटेटिव एस्टिमेशन ऑफ द कॉम्प्लेक्स इज कैरिड आउट बाय ड्राइंग एंड वेइंग द hydrated and anhydrous complex or complex is ignited to oxide and then weighed. In volumetric methods, the precipitate is dissolved by filtering with hydrochloric acid and then resulting solution is titrated against standard potassium bromide solution. In spectrophotometric method, the estimation of the metal ion is carried out by measuring the optical density of the complex. The reagent has been found to be suitable for magnesium, aluminum, etc. The reagent is a 2% solution of oxime into an acetic acid. This is the audio recording for audio visible impaired student. Thank you.